Here we have two sets of data, scores for test 3 and scores for test 4. We want to create a histogram using the graphing calculator and then describe the shapes of the distributions. So down here you can see the two sketches that I've made. Let me go ahead and show you how I created these on my calculator though. So your first step is going to be to get your data typed in. So as we've always done, stat and then edit. And as you can see, I've actually typed in both sets of data, L1 and L2, so I don't have to type these in later. So if you could pause the video, if you want to do this the same way, go ahead and get both sets of data typed in L1 and L2. So pause the video and go ahead and get that data typed in right now. And assuming you've done that at this point, let's go ahead and see what these distributions look like. And again, I may not sketch them nice and neat like I did here. If you want help sketching these with convenient numbers, go back and watch the last video. I talked about that. Otherwise, we're going to just compare what we see on the screen for the distribution. So to see your histograms, let's hit second and y equals. Now, unfortunately, you can only do these one at a time. If you do them overlapping, it gets a little messy. So let's go ahead and select plot 1. We'll want to make sure it's turned on. We want to make sure that this third option right here is selected. And then for our first set of data, the test 3 scores, we typed that in L1, so let's leave this as L1. So everything should be good to go. Make sure that those are all turned on. If you need to change this, move down here and then hit the second key and number 1 to get that to say L1. And when you're ready then, let's hit zoom. And then option 9 is zoom stat. That'll give us a nice-ish window. We talked again in the last video about how to adjust this. But for right now, that's kind of what we want to see here. Now, it doesn't look exactly like my graph down here as I've made my graph a little bit nicer, but I can see that I can see a roughly a symmetrical distribution. This end seems to be a little bit higher, but still my bulk of the data is right here in the center. So I'm going to describe this as symmetric. If you adjust it so you have a nicer looking view like we did down here, maybe you see that symmetry even better. In fact, I guess we can do that right now. Remember to adjust, hit window, and then just change these values. Let's move this down to 60, just round them to some nicer values. Let's make our high score, it looks like 100 is what I use down here. So let's go from 60 to 100, and let's just count by 5. So our bins are going to be 5 spaces wide instead of the 6.3 that was there. Now if you take a look at it, you see even more symmetry amongst your data. So I definitely see a symmetrical distribution of the data. It's mostly clumped up in the center. Okay, cool. Let's go ahead and try this. These test 4 scores over here. So hopefully this data is already typed in, and I can show you how you can very easily do this from here. So let's again select plot 1. We still want this turned on. We're still going to do a histogram. However, the difference is this time our data is typed in L2. So let's change that to L2, second, and then number 2. And so now we'll draw from L2. I'm going to hit enter too, just to be sure that's locked in. So my data is now going to draw from L2. So again, let's do zoom stats. It worked out okay, sort of, last time. So zoom and then option 9. And we'll see that. Again, kind of an ugly distribution, not very matched up to what I have down here. Let's go back and adjust it so we see a little bit nicer. Looks like I went from 60 to 95 this time. Probably 70 would have been fine too, but let's go 60 up to 95. And again, we're rounding these off so they're slightly nicer numbers. And then the scale is the width of the bin. Let's count by 5s. Okay, remember your goal is to have 5 to 7 bins when you're done, although it's not set in stone. Now if I take a look at my distribution, I can see that symmetry again much more nicely. So there's the most of your data is clumped here in the center. So I'm going to say both of these have a symmetric distribution of data. Let's go ahead now and analyze these two sets of scores and see what we can determine about the scores between test 3 and test 4. So just like our questions have asked us before, we want to start analyzing this data by describing the center and spread of it. Meaning we're going to either use the mean or the median to describe the center, and we'll be using either the standard deviation or the interquartile range to describe the spread. The one we pick depends on what kind of data we have, and since we agree, or since we talked about the fact that both sets of data appear to be symmetric, we're going to choose to use the means and the standard deviations, just what we've decided to do, what we decided to use in that scenario. So let's go ahead and calculate the means and the standard deviations for each set of data. Well, to do this, unfortunately, that data cannot come directly from our histogram. We'll have to do one more thing to run this and find this information out. It's the same thing we've been doing all along in this stats unit. So press stat, move over to calculate, and we want to select that first option, one variable statistic. So we'll have to do this twice, once for L1. So let's get second L1. So first we'll start with the L1 data, then we'll do the L2 data, and then we'll be able to compare them. So once I give my calculator a chance to run that, my mean is going to be that first option there. So my mean, my average score on the test was 81. My standard deviation, I'm going to use, it's a sigma, although it looks like an O with a hat, doesn't it? I'll use that sigma because that represents the population. We have all the data. This, I assume all those scores are all the students in class. So we don't have the sample, we have the sigma, we have the population. So we'll say my standard deviation of scores was about 9.92. All right, let's do the same thing on that second set of data, and we'll see where these numbers are coming from. So stat, calculate, and then one variable statistics. This time, though, we want to pull from the L2 data, the second list. So second 2 to get L2 to pop up. Go down to calculate and press enter. Give it a second. And we'll see that chapter 4, the mean, the average score was about 79 points. And my standard deviation, well, again, the population standard deviation, was about 5.86. Okay, so we have that data, we have all these numbers crunched. Let's go ahead and finish this by just writing at least a sentence comparing the two sets of data. So I've jotted down a couple of my thoughts here. There's more you could write if you wanted to, but one thing that I'm noticing is that the mean on chapter 3 was slightly higher than the mean on chapter 4, meaning the students in this class seem to do a little bit slightly better on chapter 3. So there's something that I could write down, just some sentence summarizing up my data. I could also say, though, the standard deviation was a little bit higher on that third test compared to the fourth test, meaning this data was more spread out. So even though the mean was higher, there was more variety in the scores. There was a bigger spread of the data. So again, we're just looking for at least a sentence summarizing that data. The more you can tell me, fine, but make sure whatever you tell me is based on math. Make sure you refer back to some of those statistics that we found throughout this problem.